Okay, here we go. Last time we talked about 1D projectile motion, dropping a ball off a cliff. This time we're going to be talking about somebody throwing something up and it coming back down. Here's a good way to start it here. So you got objects thrown straight up. They don't start from rest. Instead, they're thrown upward, so they have an initial velocity, or it could be thrown downward with initial velocity. But after thrown, gravity is the only force. Gravity is the only thing that changes the vertical motion. And because there's no air resistance, we're going to ignore it. We say that acceleration of gravity is constant. We call it negative because Earth pulls everything down. Gravity's downward. We're going to make that a negative value for the acceleration. Negative 10 meters per second squared. Here's a good example. A fellow that can slam dunk on a 12-foot goal named Mike Wilson, a basketball player for the Harlem Globetrotters. And, well, let's see. A couple of questions. Well, what's the speed when he's at the top of the jump? What's the acceleration after his feet leave the ground? And also his acceleration at the top of the jump. So we're going to look at we're going to simplify it and say, okay, instead of this fellow with a basketball, it's just a point or a little ball. And the ball is starting down here and moving up. And you can see the distance is changing between where the ball is, and that's because it's slowing down on the way up, and on the way back down it's speeding up. And when we see motion diagrams like this, we know that means it is not moving at a constant speed. So is the velocity constant? Well, no, because as time goes by, on the way up the velocity gets less. We can see that on this graph. If it started at 20, after 2 seconds it would be 0. That's the point where it stops moving up. And then after that it's going to come back down, and it's going to have negative velocity because downward means negative. And it turns out because of the acceleration of gravity, it changes by 10 meters per second every second that goes by. So this was 2 seconds going up, 2 seconds coming back down. Now I wonder if that basketball player could do that. 2 seconds going up, 2 seconds coming back down. We're going to find out about that this week. Alright, how about the acceleration? When this guy's jumping, or anything you throw up, when it comes back down, is the acceleration constant? Does it stay the same? Well, you bet. Negative 10 meters per second the whole time. That's what this graph shows, this little blue line right here. As time goes by, the acceleration stayed negative 10. So back to our fellow on the basketball court. What's the speed at the top of the jump? Well, if he's at the top of his jump, he's not going any higher. It's 0. His speed is 0 meters per second. That's true of anything going straight up. When it gets to its highest point, like when he's at the top about to dunk that basketball, 0 meters per second. Now he's going fast. He slows down on the way up, and on the way down he speeds back up. And his acceleration, well, we already said it's constant, negative 10 meters per second squared, no matter where he is. At the top of his jump or right after he leaves the floor, it doesn't matter. Acceleration is negative 10 meters per second squared. Alright, so an object moving upward, what happens to it? Well, it's going to slow down. What happens to the velocity of an object as it's moving upward? Slow down. Next question. What happens to the velocity of an object as it's moving downward? Well, something coming down is going to speed up. It's going to increase the velocity. What is the velocity of an object when it reaches its highest point, just like that basketball player? 0. Does gravity still act on the object when it reaches the highest point? This is a tough question. Pay attention. Yes. Gravity is always acting on an object, whether it's moving up or down or when it's at rest at its highest point. Always acting on it. And what is the acceleration during that time? Well, as you know, acceleration is something falling in gravity, negative 10 meters per second squared. That means the speed is changing by 10 meters per second every second, and the negative sign means it's in the downward direction. So when we calculate, we're going to use the same equations as before. The one for vertical velocity, Vf is Vi plus At, and the A is negative 10 meters per second squared. And then the distance, which is the height, vertical distance, is we use this equation, which we've already used. Now the difference here is now we're going to have a VI. Before we did not have a VI, and now we're going to have a VI that's not 0 in both of these equations. Because if you throw something up, it has a initial velocity. It's negative if it's thrown down. It's positive if it's thrown up. Alright, take a look. We got this watermelon. Somebody threw it up off the ground, 30 meters per second. How much time will it take to reach its highest point? Well, we already know at its highest point, the velocity is 0. Because that's what happens when things get to their highest point. They stop moving up. So we'll use this equation. VF is VI plus AT. And we're going to solve for how much time it takes, that T right there. The velocity is 0 at the final. The initial velocity we're given right here is 30. It's positive 30, thrown upward. A is negative 10. Solve for T. When you do that, you get T equals 3 seconds. It takes 3 seconds to go up if you throw something up 30 meters per second. Okay, on this second question, they're asking us what is the velocity when it's been in the air for 4 seconds, and we're going to use the same equation, but we're solving a different thing, solving for a different thing. VF is VI plus AT. This time we know we still know the VI is 30 meters per second. We know the acceleration is negative 10. We know the T is 4. When you do all the math right here, you're going to end up with 30 plus negative 40, which is negative 10. So, negative 10 meters per second. What that means is that when this watermelon is thrown up, it goes to its highest point, comes back down, and it goes 3 seconds up. 1 more second, it's on its way back down. It's going negative 10 meters per second because it's on its way back down, because it's after it's already reached its highest point. How much time will it take to land? Well, that one's pretty easy. We already know it's going to take 3 seconds to get to its highest point. So here's the ground. It goes up for 3 seconds. Guess what? It comes back down for 3 seconds. 3 going up, 3 going down. 3 seconds there, 3 seconds there. It's a total of 6 seconds. And then what's the velocity of the watermelon when it lands? Well, that's pretty easy too. It goes up and comes back down. If it started 30 meters per second, it ends up negative 30 meters per second if it lands at the same height. So now, a couple of different questions now. What do you do differently? What are you going to do differently when it asks you things about the distance? Well, we have a different equation for distance. It's this one that says D equals VI times T plus 1/2 AT squared. Now that's the equation that involves distance. How far above the ground? That sounds like a distance to me. The time is 1 second. The initial velocity is still 30 seconds. Let's find the distance. Well, it's equal to, the distance is equal to VI 30. Time is 1 plus 1/2 negative 10. Don't forget the negative sign. T squared is 1 squared, so it's still 1. So 30 plus 1/2 times negative 10 is negative 5 times 1. 30 plus negative 5, 25. That means after 1 second of being thrown, if it started at 30 meters per second, one second off the ground is going to be 25 meters above the ground. And when it reaches the apex, how high will it be above the ground? We'll still use the same equation, but we already know when it reaches the apex from the last slide, right here, when it reaches its highest point, the time is 3 seconds. So we can go ahead and put that in here too. T is 3 seconds. Still doing that same equation. Distance VI times T plus 1/2 AT squared. How high will it be? Well, the VI 30 time 3 plus 1/2 times negative 10 t squared is 3 squared. 3 squared is 9. You do all this math here. 30 times 3, 90. Plus all that right there, 1/2 times negative 10 times 90 is negative 45. Because 9 times negative 10 is negative 90 times 1/2 is negative 45. We're just plugging numbers in. 90 plus negative 45, 45. So what does that mean? When you throw a watermelon up off the ground, when it reaches its apex, if it starts at 30 meters per second, when it reaches its apex 3 seconds later, it's going to be 45 meters off the ground. No human alive could even get close. How high above the ground will the watermelon be when it's been in the air for 4 seconds? Still, how high? Still using that same equation. Distance equals VIT plus 1/2 AT squared. Same equation as above. I'm not even going to write it again. 30 times 4 plus 1/2 times negative 10. 4 seconds, the time of 4. 16. 4 squared is 16. That's 120. This over here, 16 times negative 10 is negative 160 times 1/2 is negative 80. So 4 seconds, what that means, 120 plus negative 80, I get 40. So that means this watermelon, if you draw a picture, this watermelon goes up, takes 3 seconds, goes 45 meters, in 4 seconds it's going to be 40 meters off the ground. At its highest point, it's 45 meters off the ground. It's already, if it gets to its highest point in 3 seconds, up here, 3 seconds to get to its highest point, 4 seconds it's going to be on its way back down, so it's not going to be as high. By the time the watermelon comes back down to the ground, it will have traveled a total distance of how many meters? Well, that's pretty easy. If it goes up 45, it's going to come down another 45 when it comes back to the ground, so that's a total of 90. You just add them up, that's all it is. Thank you very much.